I saw this video in my recommended a few months ago and clicked it thinking it would be interesting, but in reality it sucks ass. The first two facts are fine, but 3 is a little iffy. Geometry is a part of math, so I guess yeah, it's related, but you could also say that all polyhedra have at least 4 sides and all polychora have at least 5 sides, and so on, so it's a little bit random. Why does 2D get the special treatment? I'd say that the side count of a 2D simplex relates to 3, but 3 doesn't relate to the sides of a 2D simplex, if that makes any sense. 4 is the number that set me into a spiraling rage, enough to make me make this video, at least 2 months later. 4 is the number of letters with horizontal and vertical symmetry. What? That's not even remotely related to the number 4. That's completely linguistic and arbitrary. I was devastated. I had only been watching for 28 seconds, but I already felt like I had wasted eons. I felt more betrayed than I ever have or ever will. This is hands down the worst video on YouTube. A crime against mathematics and my autistic mind. But it gets worse than 4's fact. 5 is listed as the number of platonic solids, which is better, but it's still kind of weird for the same reason as 3. But 6 is listed as the first number to make a new number when rotated 180 degrees, which is even worse than the letter fact, because at least the letter fact takes into account the number's value in some capacity, 6 being the first number to make a new number when flipped. Is purely symbol related. It doesn't make sense in binary, it doesn't make sense in sextimal, and doesn't even make sense with most other symbol sets of decimal. Disgusting. I was heartbroken. Backstabbed, bamboozled. With that, I couldn't bear to watch any further, and I had to turn the video off, feeling nauseous. I fell to my knees and prayed to the John Conway shrine in my room. Look at how they've massacred numbers! The most beautiful creation of man. Disrespected! I cried. I will avenge myself and the 65 other people who disliked the video. I'll set some ground rules real quick for expectations and whatnot. I'm not giving a fact for every single number, as I tried to do that, and in practice that was really boring. I will show every number, though, in 3 bases, and show its prime factorization. It should still be relatively fun, at least for number nerds like you and me. Also, if it wasn't clear from the hyperbole, I'm joking. I mean, I really was disappointed with the video, but I understand that other people don't care about numerical purity or anything like that, and it's just a fun video. It is also more entertaining than this one. I just like numbers. Let's begin! The smallest positive integer, neither prime nor composite. The smallest prime, also somehow a superior highly composite number? 2 is both a prime and an anti-prime. If you throw 2 2's at each other, do they annihilate? Small numbers are just weird. They're everything. 3. The first Mersenne prime, a prime which is 1 less than a power of 2. It's also the first Fermat prime that's 1 more than a power of 2. As an unrelated to the value but still mathematical fun fact, every dimension after 4 has exactly 3 platonic solids. I'm allowed to put these facts in as long as they're mathematical and an actually relevant fact is included. 4. This is the first non-2 power of 2. It's highly composite, but not superiorly so. 5. Fermat prime. 6. The first normal, superior, highly composite number. Its prime factorization is the first 2 primes. It's also the number of regular convex polychora in Euclidean 4D space. 7. The 4th prime, also a Mersenne prime. 8. Another power of 2. 9. The first odd composite number. It's a power of 3. It's also the first square that I've mentioned. Not the first square, it's just that there's a lot of properties of small numbers, so I'm spreading them out a little. 9 is the 3rd square. 10. I thought this was the first boring composite number, but it's actually highly abundant, meaning the sum of its factors, including itself, are greater than the sum of the factors of any number before it. You'd think this would be the same as highly composite or superior highly composite, but no. 11. This is the last boring prime I'm announcing. The prime factorization makes them easy to spot, so there's no point. 12. The 3rd superior highly composite number. It's double the last SHCN. 14. This is one of those numbers where it's double a prime. I like these ones, they're kind of funky. 16. A power of 2, also highly abundant. 17. Fermat prime. 18. Highly abundant. 20. A dodecahedral number, whatever that means. Highly abundant. 22, two 11s, another double prime. 23, isolated prime, meaning it doesn't have a twin prime, a prime two less or two more than it. 24, another highly composite number. This one is also double the last one. 12. I like HCNs, but they're not as cool as anti-primes. 25, a power of 5. 26, a double prime, two 13s. 27, a power of 3. 28, a perfect number, meaning it is half the sum of its divisors. 31, a Mersenne prime. 32, a power of 2. A double prime, two 17s. Another highly composite number, not superior, unfortunately, also a power of 6. Except for 6, it's the first highly composite number to not be a double of the last one. Largest even number that can't be expressed as the sum of two odd composites, according to Wikipedia. It's the sum of 5 consecutive primes, 3 plus 5 plus 7 plus 11 plus 13, and feels prime itself, but isn't. First multiple of 10 that isn't highly abundant. It's highly abundant. 44. This is an octahedral number. I don't even understand the 2D shaped numbers well enough to explain them. Isolated prime. Highly composite number. Not quite an anti-prime though. It's not double the last one, but that's just because 36 jumped in. It is still double another HCN, so it's a cheater. 7 squared. An untouchable number, called untouchable because it's not the sum of the proper divisors of any number. First multiple of 6 that's not highly abundant. 10th Fibonacci number and 10th triangular number. And in base 10, the sum of its digits are 10. Kind of unlike me to put in a fact about notation, but it was on the Wikipedia page, and it has the other two 10-related facts, so I could plausibly deny that I'm talking about base 10 because of that. It's the sum of the first 6 triangular numbers, and in base 6 its digits add up to 6. See? I do it for other numbers too, not just 10. $60. Another superior highly composite number. Woohoo! And it's not twice any highly composite number or superior highly composite number. So original! Also, the number before it and the number after are both prime. Wow! A prime anti-prime sandwich. A power of 2 and a square number. It has 12 factors, just like 60, probably because 60 is 12 times 5 and 72 is 12 times 6. A power of 3 and 9 squared. An octahedral number. It's untouchable. Ten squared. This is a Perrin number. I honestly don't understand what it means, but looking at this chart I can generate the sequence. 120. This is a superior highly composite number, but it's just double 60, so it's not the most exciting thing in the world. Untouchable. 11 squared. A power of 5. a Mersenne prime. I also forgot to mention this earlier. Mersenne primes are specifically 2 to the power of a prime minus 1. Triangular number. A centered pentagonal number. 12 squared. An untouchable number, and an octahedral number. It's the sum of the first 11 primes, and it's the sum of the first 3 primes, each one raised to the third power. 8 plus 27 plus 125. This number is highly composite. (14 squared). A power of 6, and the final number for today's video. Thanks for watching. Make sure to dislike, purposefully not leave a comment despite the video's performance, and if you somehow still subscribe, smash that unsubscribe button. Temporally appropriate exit.